Welcome back, Algebra 1. Today we are going to start on Chapter 6. This whole chapter is dealing with exponents. You guys have hopefully exponents before. That would be when I'm, doing something like 4 squared. Okay, but we're going to talk about why the rule is the way it is, and then we're going to talk about other rules for exponents. This is going to be incredibly important moving forward in Algebra 2. And so you really want to make sure that you understand this stuff. If not, please get some help from us. So the first thing is why the rule is the way it is. So we're going to take x squared times x to the third, and we're just going to write it out. So x squared would mean x times x. Remember that this number up here, the x, is how many times we're doing an operation. Okay, so we're multiplying x 2 times. Okay, and then we have times x to the third power. So that would be times x times x times x. Really, how many times are x? 5 times in total. So this is called a product. Multiplying an x squared times an x to the third for exponents. Multiplying monomials with the same base, we add exponents. In other words, if we have a base of x to the power, we're going to get a b. So here is we said x squared, so that's going to be to the second power, plus the third power, gives us x to the 5th power. It's just a shortcut rather than having to write it all out. We're going to every rule so that you guys can see why the rules are the way they are. So let's go ahead and let's simplify. So this one's a little bit different because it's actually got some coefficients. So the coefficients we're going to do just like normal because they are not actually raised to a power. So we're going to do these as normal. So 2 times 3 is 6. Okay, and then we have x to the third power times x to the 5th power. So that's going to be x to the 3 plus 5, which gives us x times 6 times x to the 8th power. And that's going to be our final answer for that one. Let's move on to b. So b, we have coefficients, negative 4 and 6. Okay, we always want to deal with those first. So negative 4 times 6 is negative. And then we have y to the 4th. And this is a y to the first power. Okay? So that's going to be 4 plus 1. So that's going to be negative 24 y to the 5th. Okay? And that'll be our final answer there. Let's take a look at C. So we're going to work coefficients first. So we have a 10 and a 3. So 10 times 3 is 30. Go ahead and do these coefficients or these exponents separate because I have 2 different bases. I have a base of x, so I have x squared times x. And remember, if there's just an x, it's x to the first power. So that's going to be an x squared plus 1, which is x to the third. And then I have my y's. So I have a y to the 6th and a y to the 5th. So that's y 6 plus 5, which is actually y to the 11th. So my final answer then will be 30, and then that x to the third, and that y to the 11th. Okay, you can't. Okay. So why don't you guys go on ahead and try this next one on your own. Pause the video and come back in a minute and check it right. And hopefully you tried this. So it's going to be 9 times negative. Well, remember that's actually 9 times negative. So that's a negative 9. I'm going ahead and write these various bases down below just like I did before. So I have an x to the 5th times an x to the 7th, which is x to the 5th plus, okay, which is x to the 12th. Now let's do our y's. We have a y squared, so that's going to be a 2, plus y to the third is 3, so that's a y to the 5th. So my final answer is going to be negative 9, x, 12, y to the 5th. And you can really write it either way. It doesn't matter if you write it as x 12y to the 5th or negative 9y to the 5th, x to the 12th. We usually have the x's first when we're writing the answers, but either way is actually correct. Now, let's go on ahead and look at another rule. Next rule, we're going to call the power to a power rule. So first, let's go on ahead and write this rule out. Okay, we're going to expand it. So we have 2x squared to the 4th power. Okay? So now what that means is this whole thing right here is raised to the 4th power. So I'm going to multiply 2x squared times itself 4 times. So we have 2 times 2 is 4, is 16. So we have 2 times 2 times 2, which is 16. 4th power. So if we have a coefficient here, we have to raise it to that 4th power, okay, or whatever power is inside the parentheses. Now let's deal with these. So I have times x squared times x squared, which is really x times x times x times x times x times x times x. So how many x's are there? 1, 2, 3, 4, 5, 6, 7, 8 x's. So that's x to the 8th power. So my final answer is going to be 16x to the 8th power. So our rule, our shortcut for doing this is the power to a power rule. When raising a monomial to a power, okay, remember monomial means there's pluses or minuses here. We distribute the exponent to each base and we multiply the exponents. So it's going to be x, a times b, y, b times c. So we always multiply those exponents. And remember that we distribute the exponent to each base as well, and that's why we had to multiply this 2 to the 4th power. Okay. So let's go ahead and try a few of these. Let's see if I can get us to the next page here. Okay. So let's simplify these. So we have 3x to the 5th to the 4th. So the first thing I'm going to do is I'm going to distribute the exponent to each part here. So I have 3 to the 4th power, and then I have x to the 5th to the 4th power. Okay? So 3 to the 4th power is 3 times 3 times 3 times 3. So 3 times 3 is 9, times 3 is 27, times 3 is 81. And you can use a calculator if you can't do that in your head. This is something that I do a whole lot. We use thirds a whole, so it's just something I'm used to doing. And then we do x to the 5th to the 4th power, which is really x 5 times 4, which is x to the 20th. So our final answer then is 81x to the 20th power. Go on ahead and try the next one on your own. And then we'll see how you did on it. So try B. Okay, so hopefully you paused this and did it on your own. If not, pause it and let's try it. Okay, so the first thing we're going to do is we're going to distribute this exponent to every single part in here. Okay, so we have 6 to the 3rd power, and then we have x squared to the 3rd power, and then we have y to the 1st to the 3rd power. Okay, so the very first thing I need to figure out is what is 6 to the 3rd power. So 6 times 6 times 6. 6 times 6 is 36. Times 6 is 216. Sorry, that is my dog. She is not doing so hot right now. Okay, so let's go ahead and do x squared to the 3rd power. So that's really x to the 2nd power times 3, which is 2 times 3 is 6. And then we're going to do y to the 1st power times 3, which is y to the 3rd power. So our final answer here will be 216 x to the 6th y to the third. Okay, let's go on ahead and do the next one. So same thing, we're going to distribute this 5 to every single part inside the parentheses. So it's going to be 2 to the 5th power, x squared to the 5th power, and y to the 7th to the 5th power. So 2 to the 5th power is 2 times 2 times 2 times 2 times 2. Did I say it 5 times? It's going to be 32. X squared to the 5th power is x 2 times 5, which is x to the 10th. And then y, 7 times 5, is y to the 35th power. Once again, this is extremely important because as we progress in math, you're going to be doing it both forward, the way we're doing it now, and you're going to have to do it backwards. Okay, so it's really important that you really understand it. Okay, so our final answer here is going to be 32, x to the 10th, y to the 35th. Alright, let's go on ahead and do part D. Okay, so part D, we're going to do a little bit of both multiplication and a power to a power. Okay, so remember with PEMDAS, please excuse my dear Aunt Sally, we have to follow order of operations. So the very first thing we would do is anything inside parentheses if we could. And here there's nothing inside parentheses we can do. The next thing we would always do is exponents. Here we have an exponent, so we're going to go on ahead and do this piece first. Okay, so we're going to do negative 2 to the 3rd power, which means negative 2 times negative 2 times negative 2. Now be very careful if you type this into your calculator. You have to have that negative sign inside parentheses. Otherwise, it is not going to work right. Okay, if you type it in like this as negative 2 to the 3rd power. But really, anytime you have a negative number to an odd power, it's going to wind up being a negative number. Okay, so we can make a note of that. Odd power. So I guess it's going to be a negative number to an odd power is always negative. Okay, and a negative number to an even power, okay, is always positive. Okay. All right, so negative 2 times negative 2 is positive 4 times negative 2 is negative 8. Okay. Now let's go on ahead and we have our x squared to the 3rd power, which is x to the 6th. And then we have our y to the 4th to the 3rd power, which is y to the 12th. So now I'm going to rewrite this because I haven't done anything with that yet. So it's 4xy to the 5th power times negative 8, x to the 6th, y to the 12th. So now I'm using the product rule. So now I'm going to add exponents. Okay, so 4 times negative 8 is negative 32. X to the 1st power, so 1 times x to the 6th power, so it's going to be x. 1 plus 6 is 7. So remember, there's a difference. This time I'm multiplying exponents. I'm not raising it to a power. And that's why I'm adding them. So y to the 5th times y to the 12th, I'm going to add 5 and 12, which gives me 17. Uh-oh, my pen's going dead here. Okay. So that's going to be my final answer. But you have to still use PEMDAS, and you have to follow order of operations. Okay. Right, let's go ahead and look at the next rule, the quotient rule. In other words, when we're dividing exponents. So let's take a look at this. So x to the 5th, we're going to write it out. We're going to expand it. X times x times x times x times x. So that's x to the 5th, x 5 times. Divided by x squared, so that's x times x. Now here's a question. Anytime I divide a number by itself, what answer do I get? So 2 divided by 2 would be 1. 7 divided by 7 would be 1. 873 divided by 873 is 1. Okay, so really what happens is these cancel, and you're left with the number 1 in the numerator and the number 1 in the denominator. Okay, so what I can do here is I can divide. X divided by x cancels, and it equals the number 1. X divided by x cancels, and it equals the number 1. And I am left with just x to to the third power over 1, which is just x to the third power. Okay, so really my rule when dividing monomials is I take, with the same base, is I take my exponent in the top, in the numerator, and I subtract my exponent in the denominator. So here I had x to the 5th minus, so that's my numerator, minus 2, and that gave me that x to the third power. Okay, but here's my rule. Okay? So let's go on ahead and take a look at a couple of these. Okay, so these once again are a little different because they actually do have some numbers in them, some coefficients in them. So the very first thing I always like to do is do my coefficients first. So 6 over 9, I need to reduce this. I need to put it in lowest fraction form. So 6 and 9 can both be divided by 3. Okay, 6 divided by 3 is 2. 9 divided by 3 is 3. So now I have 2 over 3 x to the 10th over x to the 7th. So now that's going to be 2 over 3, and this goes in the numerator. Okay, so that's going to be x to the 10 minus 7, which is x to the third. So it's going to be 2 over 3 x to the third. Okay, that would be one way to write it. The other way that you can write it, either one of these is correct, is that you have 2/3 times the number x to the third. Okay, so those are both correct. And let's go ahead and try this next one. So 18 divided by 12. So what are these both divisible by? They're both divisible by 6. 18 divided by 6 is 3. 12 divided by 6 is 2. Okay, so now let's go ahead and deal with our variables here. Our bases and our exponents. So we have x to the 5th divided by x to the 1st, which gives us x to the 4th. And then we have y to the 6th divided by y to the 3rd. So we subtract those exponents and we get y to the 3rd power. Okay, so our final answer then is 3/2, and we can either write x to the 4th times y to the 3rd up on top here with this 3. Okay, or we can write it as 2/3 times x to the 4th y to the 3rd. It means the same thing. Okay, anytime we do this division, for right now, we're going to learn another rule in a minute, negative exponents, but if the exponent is positive, it stays on the top, okay, or in the numerator, okay, which means it can really be written like this because this is a number over 1. Okay, so that's still in the numerator. Let's go on ahead and take a look at this next rule. So this is negative exponents. Remember just a second ago I said if these are positive, they're going to stay in the top. Okay, but now let's take a look at this. So let's expand this one out. So x to the 3rd would be x times x times x. And then we have x to the 7th power. 1, 2, 3, 4, 5, 6, 7. Okay, so let's go on ahead. Remember that these cancel because any number divided by itself is 1. So now I'm left with the number 1 over x to the 4th power. Okay, so let's take a look at our division rule now and put that into place. So we know anytime we're dividing, we take the exponent on top and we subtract the exponent on the bottom. So we get x to the 3 minus 7, which is x to the negative 4th power. But we do not like to ever see negative exponents in our answers. Okay? So we always move the exponent and the base to the bottom of the fraction if it's in the numerator and it's negative, or to the top of the fraction if it's in the denominator and negative. Okay, so it's very important to do that. We never want negative fractions, negative exponents. Okay? It always needs to be a positive exponent. So if an exponent is negative and the base is on the top of the fraction, we're going to move the base to the bottom of the fraction and the exponent will become positive. Okay, so here's our rule. So we have a y to the a, so that's positive. We don't have to do anything with that. But this x to the negative m, the entire part, moves to the base and it becomes positive. The same thing for this one. Okay, our y to the a is positive, so we don't have to do anything with it. But this x to the negative n in the denominator has a negative exponent, so it has to move up on top of the fraction. Right? So, I'm sorry, I don't know why this printed this way, but let's take a look at the next rule. Okay, the next rule is the zero exponent rule. Okay. Oh, we're not done with this one. We have to do some examples first. Sorry. So this one is simplify. And then this one is y. And this is the next rule. Okay, so let's finish our negative exponent rule. I apologize. So we're just going to take both terms just like we have been. So we have x to the 3 minus 1. And then we have y to the 2 minus 8. Okay, that gives us x squared and y to the negative 6th. So right now I have x squared times y to the negative 6th. But I can never, ever, ever have a negative exponent in my final answer. So it's going to be x squared. That stays where it is because it's positive. And we're going to move this to the denominator, where that exponent changes to positive. Let's go ahead and take a look at the next one. So this one has some negatives in it to start. Okay, that's okay. Don't let it trip you up. Okay, so now we have x to the negative 3rd minus the negative 1. Okay, remember we always subtract that exponent in the denominator, so it's minus that entire negative 1. Okay, so that's going to be negative 3 plus 1 is negative 2. And then let's do y to the 6th power minus negative 3. Okay, and that's going to be y to the 9th power. Okay. So what that's going to turn out to be is x to the negative 2nd power times y to the 9th. We can't leave that negative, so it has to go to the denominator. The y to the 9th stays in the numerator on the top. And that x, negative 2, goes to the denominator, and the exponent becomes positive. Remember, it's only the exponent that we're changing. Okay. Alright, so now let's look at this next row. Okay, so it says x to the 3rd divided by x to the 3rd. Okay, and we've already talked about this, but let's go ahead and show you what happens. So we have x times x times x, which is x to the 3rd, over x times x times x. Now remember, what happens when I have a number divided by itself? It equals 1. So now I have 1 times 1 times 1. And what's 1 times 1 times 1? It's 1. So we know that x to the 3rd divided by x to the 3rd would be x to the 3 minus, so that's our exponent up here, minus our exponent in the denominator, which gives us x to the 0 power, and we just solved and showed that it was 1. Okay. So anytime we have any exponent raised to a 0 power, it equals 1. So this one right here, it actually has a number with it, so if it had, 2x to the 0 power, okay, well that would be 2 times x to the 0 power, which is 1, so it would just be 2. So in formula notation, it would just be whatever number it is, in this case, a. So let's go on ahead and simplify a couple of problems here. Okay, so this first one says x to the 5th divided by y to the 7th. Okay, so that's division. So we're going to take 5 minus 7, and we get x to the negative 2nd power. And let's go on ahead and do our y's. So we get y to the 2 minus 2, which is y to the 0, which is not 0, which is the number 1. So now our answer is going to be x to the negative 2nd power times 1, which is just x to the negative 2nd power, but we never, ever, ever leave this as a negative exponent. Okay, so this is in the numerator. Now we have to move it to the denominator, and it becomes x squared, and we just put a 1 on top, okay, because there's no coefficient or anything else with it. 3x to the 0 power is really 3 times x to the 0 power, which is 1, and 3 times 1 is just 3. The next thing we're going to do, and this is the very last thing for 6.1. I know it's a little bit of a long section, but we have to remind you of some of these rules. We have some rules of rewriting exponents using the radical symbol. So if I have x squared, okay, so if I have x to the second power, okay, the opposite of that, right, would be square root of x. Okay, so if I took the square root of that, then I would just have the number x. Okay, so I need to make sure that I understand what these rules are and how they work. So the way I always like to think of it is here I have an x to the, or an a to the 1 over n power. So how I rewrite that is whatever's in the numerator stays with my number or my base, and then I put my radical symbol, and whatever is in the denominator of that exponent is the root I'm taking. Okay? So a to the 1 over n would be written as a to the 1 over n. And the reason I like to think of it this way is because x squared, okay, now I'm just going to erase this. You guys can either leave it or erase it. Okay? But I like to think of the square root of x. Okay? And I just know that the square root of x is x to the 1/2 power. So that 1 goes here, and that imaginary 2 goes there. So you can remember, you know, by thinking of that and writing that out so you know it, or just remember this formula here. Okay, so the same thing for this one. So the denominator always goes on the outside, and the numerator always goes on the inside. Okay, so I'm going to rewrite this using rational exponents. So rational just means that it's a rational number. Okay, it ends or it repeats forever. Okay, so I have my base. The number that's on the inside with it goes in the numerator, and the number that's on the outside goes in the denominator. And that's it. I've now rewritten it. Okay, so now we're going to work on solving some problems using exponents. And so this is something you guys have not ever seen before. So especially this part that we just talked about and this one. Okay, these are something you've never seen before. Okay? So let's talk about the steps. Okay, so I have 27, okay, the number 27, and it's all raised to x minus 4. And then I have a 3, and it's all raised to 2x minus 6. So these two numbers here are my exponents. I can't solve a problem if I have a variable in the exponent. Okay? I have to do something to rewrite this. So now I'm going to rewrite the larger base with the same base as the smaller one. So I have my 27 here, and I need it to be 3 to some power because it has to match my smaller base. Okay, so 3 times 3 is 9. 3 times 3 times 3 is 27. Okay, so that's going to be 3 to the third power. So what I'm looking for here then is 3 to the third power. Okay, so now I have 3 to the third power times x minus 4 equals 3 to the 2x minus 6. Okay. So now it says use the power or a power rule. And what this really means is that these right here are going to cancel. Okay, those are going to cancel out. They're going to go away because they're the same base. Okay, so same bases cancel. And we get more into a lot more detail in Algebra 2 in this, Okay, but we just want to introduce you to it right now. So now all we're left with is 3 times x minus 4, and that equals that 2x minus 6. So now it's just a regular equation that we can solve. Okay, so let's go on ahead and solve it. So we have 3x minus, so I'm just distributing. 3 times negative 4 is negative 12, and don't forget to distribute, equals 2x minus 6. Okay, so let's go on ahead and subtract 2x from both sides. And we get x minus 12 equals negative 6. Add 12 to both sides, and we get x equals 6. Well, let's go ahead and check this. Right? So x equals 6, we're going to just plug it back into this. Okay, you don't have to, but I want to show you guys that it does actually work. Okay, so 27 to the x, which is 6 minus 4th power, equals 3 to the 2 times 6 minus 6. 27 to the 6 minus 4 is 2nd power, so that's to the squared, equals 3 to the 2 times 6 is 12, minus 6 is 6th power. And if we just go ahead and get our calculator out, and I'm just going to show you that these match, okay, when I do them. So 27, I use my calculator. If I'm not just squaring a number, I have to use this little caret symbol. Okay, to the squared is 729. And now let's do 3 to the 6th power, and I get 729. Okay, so I can check my work just like I can when I'm solving regularly. Okay, but very first, I remember I cannot ever solve something, okay, when my variables are in the exponents. Okay, I can't solve for x or y or z if it's an exponent. Okay, I have to get it so that these bases match, because then they will cancel, and then I can solve it just like a normal equation. Okay, so x equals 6 is my answer here. So once again, I know this is a tough concept. Okay? Most of the other stuff you guys hopefully have seen before, but these two sections right here are probably brand new. So make sure that you do your problems on those and that you practice them, because you're going to need them, okay, as we progress in your math classes. Have a great day, and I will see you all next time.